semi-annual and other compounding periods. Up until now, we've been dealing with annual compounding. Your mortgage or your car payment, if you have one or both of those are likely computed with monthly compounding. So, but we can, there's, annual, semi-annual, quarterly, monthly, daily. So and when we do that, we have to adjust the number of periods, and we have to, which I'll show you in a second, on the calculator, we have to adjust the rate. So, for example, if we have monthly compounding, we're going to multiply the number of years by 12, and then we're going to create an IY. We're going to divide the rate by 12. So, future value of lump sum will be larger when rates or interest is compounded more often with the stated net rate, because compounding is more frequent. The interest is going to be earned or paid more often, so you're going to have more compounding or more interest on interest. So compared to annual compounding, the greater amount of interest is earned when interest is compounded more than once a year. So we're going to see that. We'll go back to our original example. So we had $700 at 10% for 3 years. So 3N, 10 IY, 700, we enter that as a negative, 0 payment, compute future value. So recall we got $931.70. So now we're gonna change N. So N is going to be 3 times 12, 3 years monthly, 36, 36N. Now IY is 10 divided by 12. It's a monthly rate. So 0.83. Important thing here, 0.83. I guarantee you this number goes on probably forever. The calculator will do calculations with at least 10 digits. So if you type in 0.83, you're going to create a rounding error. So just press IY and then compute future value. So our $931.70 grew to $943.73. So I don't know why the book has this R simple. R simple is meaningless. R simple is the APR, so annual percentage rate. So you can pretty much ignore the whole, because all loans are quoted. They're required by law to be quoted at the APR, annual percentage rate. For the most part, the investments returns are calculated at the effective annual rate, because the effective annual rate is if the compounding is greater than annual, the effective annual rate is greater than the APR. And we'll see that in some calculations we do. But the APR does not include the effects of compounding. The EAR, effective annual rate, does include the effects of compounding. So, and ignore what we just calculated. We're going to ignore R simple, but the periodic rate which is what we just calculated on the calculator. Our 10 divided by 12, that's our monthly rate. That's our periodic rate, or rate per period, in this case monthly. It's what we use in calculation. When we're talking about investments, we'll compare the effective annual rates, because we might have different compounding periods on on those investments. So the APRs might be slightly different. So ignore our simple, but the 9% compounded quarterly. I'm actually going to calculate APRs here. I mean, those are APRs, EARs. So there's a function on your calculator. So we got 9% compounded quarterly and 9% compounded daily. So we go to our calculator. We'll go over here. So we had second in this ICONB. Then the nominal rate here is the APR. They could have made this function a lot better if they'd have just called this APR. But nom, so 9, enter, and then CY is the compounding periods per year. So quarterly is 4, so 4, enter. Then this register also goes in a circle. So if you go up or down. So, and then EFF is effective annual rate. Again, they could have made this function better by calling it EAR, but in compute, 9.31%. But 9% compounded daily, all we have to do is come down here to C/Y and enter 365, enter, go up to effective and hit compute, 9.42%. So it went up, the rate went up because of more frequent compounding. So if we saw the annual interest or dollar amount of interest is going to be different because the compounding periods per year differs. So so in our compounding, the 9% compounded quarterly, that's 4. And then so our rate per period is 2.25% per quarter. If we do monthly, that's 0.75% per month. If we go back to our calculator, we can go down here and do 12 as well. 12, enter, and then go up here and hit compute, 9.38%. So, not surprisingly, the effective annual rate of monthly compounding is greater than quarterly and less than daily. So there is a formula that we will go through here in a second. So this is the effective annual rate, or EAR, is equal to 1 plus the APR. So ignore APR and R simple are the exact same thing. This is just the author's trying to make things complicated. So 1 plus the R simple divided by the number of compound periods, and then we need this to the power, in this case to the M power. So we can also use our periodic rate to the M. So so example, on the next page we have 12%. 12% compounded monthly, so it's 1 plus 0.12 divided by 12 to the 12th power, so minus 1, so that's 0.1268, or 12.68%.